Right now, the universe might be splitting into countless parallel universes, each one with a new version of you in it. You probably thought the multiverse was just something from the movies, but quantum mechanics tells us it really could be true. And this weird quirk of quantum mechanics has led some people to believe in quantum immortality, a way to live forever. By the end of this video, I guarantee that you will understand quantum mechanics better than anyone else you know, and it might keep you up at night. Our story begins in the early 1900s, when physicists were first coming to understand quantum mechanics. Einstein, Planck, Schrödinger, all of these brilliant minds were coming together to develop the theory. And it worked remarkably well. By treating light both as a particle and a wave, so many problems in physics at the time started to be resolved. But there was one problem on everyone's mind. What quantum mechanics was implying was both supernatural and deeply puzzling. In classical physics, everything is exact. We can measure exactly where the Earth is, exactly how fast a rocket is flying, or exactly how much you weigh. Everything has a definite and measurable value. But in quantum mechanics, this just isn't true. Everything is instead measured with probabilities. Physicists use something called the wave function to figure out the probability of each outcome. Maybe the wave function says there is a 25% chance that I'm here, 25% chance I'm here, and a 50% chance that I'm over here. In the 1920s, Niels Bohr and Werner Heisenberg described a physical explanation for how this process worked. They claimed that the wave function collapses to one of these possible results when measured by an observer. This is known as the Copenhagen interpretation of quantum mechanics. And that feels weird, right? Why do we need to observe something for it to have a definite value? And Einstein agreed, famously saying that God does not play dice with the universe. This is actually where the famous Schrödinger's cat thought experiment came from. Schrödinger didn't like the collapse interpretation, and so he used his cat to show how weird it really was. The cat in the box ends up being both dead and alive at the same time, literally. But how can that be? So people rush to try and come up with different explanations. Maybe it's our human consciousness that is causing this wave function to collapse. But the equations just worked so well. Without quantum mechanics, we wouldn't have our computers, Wi-Fi, lights, GPS, phones, you get the point. But there is still this underlying weirdness we still don't understand. In the frustration of all of this, a young American physicist would go on to propose a radical solution that would shock the world. What if the wave function never collapses? What if it's the multiverse? Imagine we have an electron that is about to move. It could either go left or right. The traditional interpretation of quantum mechanics, known as the Copenhagen interpretation, says these two possibilities are in a superposition, existing inside the wave function. This just means there is some percentage chance the electron goes left, and some chance it goes right. These percentages can be worked out by analyzing the complex wave function of the system. This creates two possible future states of the universe, one where it goes left and one where it goes right. It's said that when we observe this electron, watching to see which direction it goes, the wave function is forced to collapse. One of the two options is the measured outcome, and that's the state of the universe that survives. The other possible future universe can never exist. In this interpretation, our universe is just a long series of these decisions, each outcome allowing just one possible universe to exist. And here's where things get interesting. What if we take a different approach? This time, when our electron is faced with the two options, go left or go right, our universe splits into two very real universes. In one universe, the electron goes left, and in the other, it goes right. Physicists call this process branching. As soon as a quantum decision forces our universe to branch, the new universes can never interact and talk to each other. And as you can imagine, considering how many little particles there are in our universe, constantly moving around and being faced with these quantum decisions, this branching is happening all the time at an insanely high rate, practically infinite. So which universe are we in? Well, your consciousness can be thought to be just a passenger riding along one of these infinite paths. Alternate versions of you exist on their own unique path, each one never overlapping with yours. So now there's a version of you that saw the electron spinning clockwise, and there's another version of you that saw it spinning counterclockwise. And that's just taking seriously the prediction of quantum mechanics. It's not adding any extra stuff, any extra worlds, anything like that. That is the part where my brain broke. This radical new approach is known as the many worlds interpretation of quantum mechanics, and it's what 27-year-old Hugh Everett proposed in 1957. If the wave function never actually collapses, All of these possible outcomes can be made real in their own unique universes. Multiple versions of the observer emerge, but they can never communicate with each other. Instead of just treating this one isolated quantum system under the wave function, in Everett's view, the entire universe could be described with one single universal wave function. When he took this revolutionary theory to Bohr in Copenhagen, he was unimpressed and said that it was too extravagant. The wider scientific community just kept using the Copenhagen interpretation. It's what I got taught at university 2 years ago. Everett left academia, never publishing in physics again, and in his later years he may have even bet his life on his theory. Now, just before we dive into the real physics of quantum immortality, I need to thank the sponsor of this video, ODOO. As you should know by now, ODOO is an all-in-one management software that gives creators and entrepreneurs tools to simplify their day-to-day management. I love making these videos. Spending time researching and animating is honestly my favorite part. But one part I don't love is dealing with all the boring admin tasks like tracking expenses. Thankfully, ODOO Expenses keeps everything organized into one place and will save you time when running your business. You can submit your expense receipts from your computer, phone, or even just by emailing. Then ODOO groups all of your relevant expenses into a single report, speeding up the approval process. You, your team, and your manager can then even directly communicate, such as adding comments, explaining or clarifying specific expenses right in the app. Managers can then easily review and approve them. Everything gets automatically processed in the accounting books, and it's as easy as that. The best thing is, your first app with ODOO is completely free for life with unlimited hosting and support, so you can try it out today completely for free with no strings attached. There was still this one big glaring problem that the many worlds interpretation was yet to answer. If the collapse of the wave function never actually happens, why does it appear to occur when we make quantum observations? All of our experiments point towards this collapse being real. So, what's going on? Well, in the 1970s there came a breakthrough. When you have a quantum system in isolation, meaning it's not interacting with the environment around it, the information contained within the wave function is easily and predictably given by simple wave patterns. These waves can be easily measured and solved to understand the quantum system. This is known as coherence. However, when you take that quantum system into the real world where it has to interact with the environment filled with things like atoms, photons of light, and temperature, it becomes unavoidably entangled. That simple relationship vanishes beneath the noise of the environment. This is known as decoherence, and it's the key that unlocks the many worlds interpretation. It explains why we never see this blur of contradictory outcomes in our observations. The alternatives quickly entangle with the environment, giving us just one definitive result. A Copenhagen believer would say this just looks like the wave function has collapsed. But many worlds tells us something more subtle happened. Decoherence locked each outcome into its own non-interacting world. The multiverse is formed. This is exactly what many worlds needed to become a real, viable theory for quantum mechanics. It allows this interpretation to keep all of the successes of Copenhagen and removes the weirdness that Einstein and Schrödinger disliked. There is no special role given to the observer anymore. And it shows. When you poll physicists today, the many worlds interpretation is endorsed by around 20% of the community. Still second to Copenhagen, but rising in popularity as time goes on. This is a simultaneously existing reality, where the outcome of a quantum mechanical experiment turned out differently to ours. Things have definitely heated up now that quantum computers are emerging. Some people argue that they are literally indirect evidence of this quantum multiverse. While classical computers like the one you're using to watch this video and subscribe use bits, zeros and ones to perform their computations, quantum computers use the wave function probabilistic nature of quantum mechanics to perform calculations exponentially faster. Instead of one bit being either a 1 or a 0, each qubit is placed in a superposition of both 0 and 1 at the same time. This allows for multiple computations to be run at the same time in parallel. David Deutsch, one of the biggest proponents of many worlds, takes this a step further. If you take a quantum computer with 300 qubits and you perform computations with it, you are essentially running 2 to the power of 300 classical computations in parallel. Deutsch says that these classical computations are literally being performed in parallel universes or branches. That's why the computational power of quantum computers is just so much greater than that of our classical computers. Okay, if this is all actually true and the quantum multiverse is constantly branching, creating new versions of you and I, Do we ever actually die? Quantum immortality. Take two branches representing a terrible accident like a car crash. In this one you died and in this one you survived the crash. Believers in this quantum immortality would say that your consciousness navigates this branching, living on in the universe where you survive, while the other version of yourself dies. While to some physicists this is just a fun thought experiment, others take it more literally. Hugh Everett, the creator of the many worlds interpretation, is said to have firmly believed that his many worlds theory guaranteed him immortality, that his consciousness will follow whichever branch does not lead to death. He never wrote this down in his papers, but second-hand accounts from people who he worked with and from his family seem to suggest that this is what he actually did believe. This is, of course, really controversial and starts to reach beyond the limits of what many worlds is actually saying, but it's worth thinking about. Perhaps those near-death experiences we all remember are really just branches in the quantum multiverse where we just so happen to survive in one of them.